All right, it is 7:05. We should try and stick to our time schedule. I want to try and be conscious about it because we definitely ran long last week. So we are going to take a look at embedded programming this week. We're going to see sort of what is going on. And that's the coded way to say we're going to do Arduino week 1 of many Arduino weeks. We're going to cover Arduino multiple ways and at multiple levels of depth throughout the entire foundations course. And so I think it's important that as we're thinking about embedded programming, we know that it's not a thing that you can take on in one go. It might be possible to build a cool lamp in a week, or it may not be possible to build a cool lamp in a week. But learning all of Arduino in a week is definitely not possible. So we're just going to get started with it. We're going to take a look at what it is, try and define it, and try and go through the logistics of how you get started. And then we'll build from here. So here's generally the plan for today's class. We're going to define embedded programming. We're going to look at what is an Arduino. We're going to think about what are alternatives, because lots of you have already asked me, like, what about a Raspberry Pi or these other things? And so we'll start to explore what those are. We'll try and figure out how an Arduino interacts with the world, but that's definitely something that will be for it's got its own whole unit. So we'll just start that discussion. And then the second half is definitely more of a how-to with Arduino for these starter concepts. So we're gonna sort of go after this 2 ways and try and get it all buttoned up nicely in an hour. So I've definitely got a watch on to keep an eye on this. It's important that we keep an eye on time. Last week I waxed a little long because in pandemic times, it's nice to talk to people. So in any case, let's keep going. The question to be answered at first is, what is embedded programming? So what is it in any sense? And here I've just got some code, but essentially it's something that you find in your everyday life at this point very commonly, including in the lamp that Ruby was just talking about having gotten. It shows up in 3D printers, in coffee makers, and in crazy Rube Goldberg machines nowadays. Embedded programming is something that has become ubiquitous, and we just sort of imagine that it's baked into pieces and parts of the world, even though it's something that comes with very deliberate engineering effort. But essentially, it's just code in a thing. That's the shortest way to define it. Any device that runs small, simple code for logic has some programming in it. We're going to explore Arduino, but it's just one of many things in this space. There's also other ways that you can build functionality like this into objects. Like you could do hardware logic to make things sort of have if-then sequencing. Light switches don't have embedded programming. They just have logical circuit programming so that when you flip the switch, the light is on or off. And then things like furnaces have more analog processes, more like transistors and switches and relays that make for a process where you can really understand the way that they work without having any code that's in them. And sometimes the choice for code or no code can be one about safety and stability. A bug in your code can be very problematic. And so there's times where you want to avoid code at all. And there's other times where code just needs to be written in a way that bugs aren't a problem. So embedded programming is something that'll take us a while to unpack. So we can't completely define it right now. But what we can do is define what is an Arduino. And so Arduino is something that you have heard me talk about before. I've got lots of examples of projects that we can look through. But an Arduino is an open source board. And so here I've got a big picture of an Arduino Uno for us to take a look at. The Arduino Uno is I would say the flagship Arduino. It's the most iconic one of all of them in the lineup. And we'll see it's a very big lineup. But an Arduino is totally it's a little circuit board that's about the size of a deck of cards. And the entire board is all there with all those components, all the things that you see on it, basically just to get to that one chip, the big black rectangle, sort of off center from the middle of the chip. This ATmega 328P is the logic that everything on the board is subservient to. It's all just trying to give you access to the pins on that chip, or set it up so that it can talk to your computer really nicely, or let you be able to reprogram it, or see if you're transmitting, receiving, giving you some steady, consistent timing. This guy up here at the top is managing how power works with that chip. There's lots of different pieces and parts to the board itself, but basically an Arduino is just giving you access to a single chip. And that chip isn't going to be a full computer. It's just a little tiny microprocessor that lets you handle a certain amount of code, use it to run what happens with the pins that come off of it, and apply voltage or not, or read if there's a voltage or not a voltage. Fundamentally, it's all queued up so that this one little thing will work for you. The nice part about Arduino in a broader context is that it's got the hardware part, but then it's also got the software piece. So in addition to the hardware of the Arduino, this actual physical thing, you've got the compatible, whoops, wrong direction. There we go. You've got the Arduino IDE. The physical board is one half of the Arduino experience, and the IDE, or the development environment, the integrated development environment, is the other half. And the fact that they work together so nicely came from a large concerted effort from 4 Europeans, 3 Italians and a Spaniard, and they're always very clear. But Massimo Bonzi is the one whose name I know off the top of my head. But they worked together as a team to try and build a platform so that people could learn how to use electronics in a hobby sort of way, or in an application kind of way. And they were specifically thinking about, how can we make electronics accessible? How can we make programming and embedded programming and physical computing accessible to people like art students within a weekend, right? After a weekend or so of study, even if they're not building very complicated things, that they're building something that can blink or respond or do something interesting after about a weekend's worth of work. And so Arduino is what was born from there, which is really an interesting thing. And the Arduino IDE is a big part of that. It integrates with the chip. It lets you write code here and then send it to the chip. It takes care of lots of the steps that happen secretly without you needing to know what they are, to go from the code you write to what actually runs on the chip, the like zeros and ones. And it's got other functions too. It lets you talk to the chip. You can have a serial monitor where you have an open line of communication back and forth between a computer and an Arduino through a hard wire. But there's lots of different interesting things that Arduino does that includes the combination of the board and the IDE. And so those two things together can be really a powerful tool, and what we're going to be focused on for the course of the week and the next couple of weeks. So Arduino is a big environment. It's got a large ecosystem for sure. These are all just shots of, these are screenshots taken from the Arduino website, where they listed off all of their official Arduino variants, all of their official Arduino boards. And so if you've wondered about what Arduino is and like where they are, there's tons and tons of options, and you could have seen any number of these and been told that this is an Arduino. The Arduino Uno is the one that we've purchased for you all. We're getting people Arduinos. Kate assures me that they're coming in on Wednesday, you said? Is Kate around?
Yes, sorry, I was nodding. Yep, that's what FedEx tells me.
Okay, FedEx says that they're coming in on Wednesday. So we're expecting Arduino Unos for everybody on Wednesday, which is really exciting. But then there's all of these other different variants of Arduino. There's tons of them, and some of them are retired, like some of these middle ones are retired. The ones on the left are sort of the recommended starter pieces. The Arduino Mega is definitely one of their more advanced boards. It's got more complicated, a more complicated chip at its core. You can see the big square in the middle, and then more pins as a byproduct, and more memory and processing power and all of that. The Arduino Mega was at the core of a lot of the early generation of 3D printers that hit the desktop consumer market. It's a more powerful version of the Arduino Uno, and something that you can upgrade to if you've got a project that demands it. Choosing one of these is definitely tricky, but I would say that by and large, you should start almost all of your projects with an Arduino Uno. Not because it'll be the best fit, but because it's got a really convenient USB plug. It plugs into the computer nicely. And usually this will take you a long way before you really hit its limit. And so most projects will be totally fine with this. And usually a lot of good starter projects, they're fine with even less. An Arduino Uno is sometimes even overkill for what projects really need. And so we'll see that that's the case as we're playing around with things. Every single one of the items for this week's work will be totally have too much power from an Arduino Uno, but that's completely fine. It's good to have something that gives you a little overhead for sure. And then we'll see how you can try and match your Arduino to the task if you need to. But starting with an Uno is always a good rule of thumb. But lots of you have asked and wanted to know, like, what are the other options? Like, what are the other things that are out there? And so there's tons of alternatives. There's tons of things that aren't quite an Arduino, that aren't officially an Arduino. So up here, I've got Raspberry Pi and Debian Linux. There's 2 Raspberry Pis. This is a BeagleBone Black. I've seen those in renovations of pinball machines. These are Adafruit. This is the Flora and the Gemma. This is a microbit. Here's an Adafruit Feather. There's Circuit Python. If you don't like coding in the Arduino environment, you can code in Python. And so there's tons of different options that are alternatives that are sort of in this space. And our choice to stick with Arduino isn't one that means that Arduino is actually objectively better. It's just that for the sake of being a class and like having a shared experience, it's good to pick a common thing to work on and then build those skills. And essentially, once you've learned the skills for Arduino, they really quickly translate out to all of these other alternatives. So I think it's good and helpful to stick in one environment and really dig your feet into the sand a little bit and feel comfortable there before you branch out. And you could make a really good argument to say that we should have done that in Raspberry Pi because it's a whole computer instead of a microprocessor, instead of a micro controller. You could make a good argument that microbit is a great place to start. This guy down here, most of England has argued that that is true, but there's lots of reasons to play around with these other ones. But Arduino is good because it starts off really close to a breadboard, so that you can easily plug in electronics without having too much extension or too many extra pieces. Like the microbit doesn't plug well, it doesn't play well with breadboards without other attachments, whereas an Arduino is pretty much ready to go out of the box. And the Arduino is a little bit more robust than a Raspberry Pi. I've killed Arduinos in the past, but it takes a bit of abuse to make it happen. Whereas a Raspberry Pi, if you give it the wrong voltage or connect the wrong leads, you can fry the chip relatively quickly. Even though it's unlikely, and they're amazingly hardy for what they are, it is possible. I have killed more Raspberry Pis than I have Arduinos. It's just easier to do, I think. And so Raspberry Pi is a great place to go. You can get to more advanced projects, but Arduino is where we're going to start. So other ways to explore alternatives to Arduino, just in case you're curious about like a little bit more about these, you can actually run programs for an Arduino directly from a chip, which is a neat, oh yeah, the Orange Pi is one that I'd have to Google. That's a good question, Kate. I'm not sure exactly what the Orange Pi is. I'll definitely if you can put a direct link in the chat, that would be cool to see. But I feel like it's probably just a variant of Raspberry Pi. Arduino and Raspberry Pi both have open source architecture, or the open source schematics. And so with that, lots of people can take those plans and do deviations from them. And we're going to see that, I guess, in the next slide over. One of these. And so once you have your open source software, people can make lots of variants that are knockoffs, that are good or bad or in between. But if you're just trying to think about what are your alternatives, cool, we'll take a look at that in a second. What are the alternatives? You can actually do all of the things for an Arduino directly from the chip itself. So if you buy a bare ATmega 328P You can run Arduino programs directly from the chip without needing any of the supporting board. And if somebody who's in the class is already a pro at Arduino, this is my challenge to you for the week, to figure out how to get a bare chip with a breadboard and a few other parts to turn on and run a program, even if it's just a blinking hello world, a hello, like a blinking LED. It's a really good project to go one level deeper and be able to remove the Arduino board itself from that equation. It is tricky though, but it's totally possible. And if you want to take something to like sale as a final product, you definitely want to move past the Arduino board and buying those, because Arduinos, when you buy them through the proper channel, they're like $30, whereas the chip can be, I think for the AT Mega, it's maybe $2 if you're buying them individually. And if you buy them in bulk, maybe 75 cents. The AT Tiny 44, and then there's even smaller ones. These are more like 10 cents a pop. So they definitely get cheaper if you can get down to this bare chip level. And if you're building a Keurig, you would totally do that because you're building millions of them, which is interesting. But it's worth it, I think, to take a deep dive into the Raspberry Pi, and we'll look at the Orange Pi in a second. But the Raspberry Pi is different from an Arduino because it is, in fact, an entire computer. And it may not look like it just from looking at it on its own, but it's got an HDMI output. There's a couple of USB ports. There's a network jack. There's a few different connectors that come out of there. A Raspberry Pi is a complete system on a chip. And then the board supporting it lets it have all the connections that chip needs. And so a Raspberry Pi is awesome. They're super powerful. I love using them in projects. But they're different than an Arduino because they have their own whole load of things. You need to learn how to deal with the Linux operating system. How do you load the code? Where do you run it from? How do you get it to run at startup? Like there's some different interesting questions that a Raspberry Pi invites you to ask and answer. And they're super useful for learning in projects. England really has broadly embraced them, but they're definitely, I would say, a bigger scale project to take on than an Arduino. If you learn the concepts of Arduino and how to deal with Arduino circuits, you'll be able to pretty quickly translate them to Raspberry Pi projects if you find that your limitation is computing power and not like the hardware. If you can figure out the hardware part, but need more brain power, a Raspberry Pi is a good place to take it. Another thing that's really neat about a Raspberry Pi is that it's super easy to do a factory reset of your entire computer's brain. Normally, if you wipe a computer's hard drive, you've got a rough afternoon trying to get it back together. But with a Raspberry Pi, it's a really easy thing. There's a whole file called noobs that you can just install the operating system on a new SD card. And if I were teaching in a classroom where kids were playing with these, I'd have just a bunch of those SD cards ready to go. So if a kid completely wrecked the operating system, you pop out one SD card, you pop in the next one, and they're good to go again. So these can be really easy to reset, which is really helpful if you've got a classroom full of kids trying to learn how to do computery stuff. So there's some interesting value there. And if we hop back over to the chat, I want to grab that Orange Pi just to see what that is. Orange Pi versus Raspberry Pi. Oh, it looks like, yeah, it seems like it's probably Orange Pi right here. There's the logo, the single board computer. Yeah, they're just in the same space. It's just a competitor. So it looks like it's a similar thing. They've got a different chip at the middle. Instead of the Raspberry Pi, which has an ARM chip of one particular type, here's an ARM chip of another particular type. And an ARM chip is just like a class of processor. Like the brand new, just came out last week, MacBook Airs. Those are also ARM processors with the brand new Apple M1 thing. That's apparently very nice. And so it's just another class of processor. It looks like Orange Pi has separated themselves only by color, rotating their chip 45 degrees. And oh yeah, it looks like it's got a little bit more operating systems it can run. And I bet the information there, it says that it edges out the Raspberry Pi in processing power and RAM. That was probably true for the 3B Plus, but now the Raspberry Pi 4 has made big gains in how powerful they are. All of these systems on a chip keep getting cheaper and cheaper and cheaper. And I think if we were to imagine, like we just had to buy a laptop. My wife's hinge on her laptop died, so we just bought a new one. And it's almost a system on a chip, the laptop that we bought. And I think that as you imagine buying a laptop 5 years from now, they're all going to be systems on a chip like this because their processing power is going to come in line with what you need a desktop computer to be on the daily basis. So there'll become a point where a Raspberry Pi is hardly a comparison, hardly a deficit from a regular computer. Maybe not a great high-end computer, but a computer that can browse the internet. So there's some neat things to take in there. And there's a lot of options for different alternatives. But a lot of the time when you get an open source platform, slight variants will show up pretty quickly. And so, presenting, I'm in the way of the present button. There we go. So other microcontrollers in general, all of these clones show up when you've got your open source software. So like I think we're buying you this one, the Inland Uno 3, which is absolutely a great board. It's made by Micro Center, which there was one, I was super familiar with these. They were always on sale and less than $10 a pop. And it's the same exact thing as an Arduino in all of the important ways. It's just different branding. So this sort of a clone is really great. Sometimes you'll take people with, and what they're doing is they've got all of these chips are sold by different manufacturers, and they just take the designs, the plans, and they get these boards manufactured and they solder on the components themselves, never interacting with Arduino, the company, other than using their plans and designs. So this can be totally great. It's problematic when somebody takes the design and they make the choice to choose the cheapest options they possibly can, because at some point you get diminishing returns. So a good clone is great because it's a cheaper option. That's the same thing. A bad clone can be really frustrating because it doesn't work in ways that are hard to troubleshoot. So we bought you some that are, I would say, good clones. A real Arduino is $30 some a pop if you're buying them at full price. And so that's a little dicey. Better to save $1 and buy more components later. So other things that are other microcontrollers in general, you've got the Flora and the Gemma. These are very much, here's the ATmega 320 or 32U, so a slightly smaller processor. But there were variants that had basically a 328p, and so slightly different chips at their core. The good news about the Arduino IDE is that they've taken into account that there would be different chips at the heart of boards, but trying to solve the same problem. And so they abstracted away the differences that existed between the different chips. Like here's the Adafruit Feather Huzzah, I think. And so it's got some processing coming out of this ESP32, this chip over here that also adds in, it looks like this one might be Bluetooth or Wi-Fi. Yeah, that's an 8266. So this one adds in full Wi-Fi, and the chip underneath this little metal can do some processing for you. This is the microbit, and that's the show side with all the LEDs. The other side is basically just an Arduino with a slightly different form factor. They've got these large tabs that are easier to put alligator clips on, and maybe has a younger target age, which is why England really leaned hard into this as a platform to use in their schools. There's other interesting things that come as a result when you make your code open, when you make your platforms open source, like little bits down here. These are a fan favorite for really young kids. These have magnetic snaps, so you don't need near the fine motor skills of all of the rest of these boards. You can literally snap them together easier than Legos. The magnets self-align, they make the connections that you want to make, and then you can write all your code in block. So I've seen kids as young as 3rd and 4th grade really meaningfully engaged with the microbits down here, so that they can, or not microbits, with the, what are the little bits. Those are called little bits. The names all get pretty close. These little bits all put together, they can make interesting things. So you've got lots of sensor modules and logic modules that you can play around with. But basically, this is a good bit of engineering where people took models, or they took the idea of an Arduino and they made it into something. So there's almost no hardware barrier for very young children. They can just say, oh, I want it to be able to see color, or I want it to be able to feel pressure. And they just snap on the right part, and it's a little bit of block code later, and it can be working. So there's some really neat benefits to making your hardware open source, in addition to getting all of these cheaper clones. I would say that if you're interested and you find this valuable, it's worth it to buy an original Arduino from the Arduino Foundation, just as sort of like your vote of support for what they do. And if you're downloading the software, you'll see later that there is a donation button if you're so inclined. But let's see. How does the Arduino itself interact with the world? And that's a really good question. One that this diagram, which is pretty wild to look at, and do not try and make sense of it all right now. Like I haven't made sense of all of this at this point, and I've been playing with Arduino for years, since 2012, maybe, something like that. And so these are just all of the different things that the pin can do. And I like this particular one because it really shows this is the chip itself, right? And the chip has a lot of these patterns and you can see a lot of the same language as what's on these pins out here. I think it does a nice job of drawing out the fact that the entire board is basically just trying to bring you access to the chip itself. And so if you're interested in trying to figure out how to make just the chip work, it's really just one layer deeper than getting the board to work. There's only a few differences, but the board definitely has its conveniences. 100%. If you're new to this, I would say start with an Arduino Uno board. But this is a great reference if you ever get stuck on like, where can I plug something in? An image like this can be really helpful for knowing what and where things can go. And the legend down in the bottom right is really, really helpful. A quick overview, all of these pins on the right from 0 to 13, these are all digital pins, just so that you know. And I would say only use from 2 up to 13. If you've got something really fast going on, you'll want to use 2 or 3. There's interrupt pins in there. In the analog side, these can read analog signals, which may not mean much right now, but that's useful. They can also be digital inputs and outputs as well. They get to be analog in addition to being digital. So that's good to know. And then here's sort of your power strip on this side. But this one slide is trying to get at how does the Arduino really interact with the world? And it's through digital logic that's cleaning up the analog data. The world is always going to be an analog world where you've got voltages that float around. Last night there was a thunderstorm, so you've got crazy voltages in the sky and on land. There's voltages shift around. They don't have to fit into neat boxes, but our digital systems, and really it's a lot of work that could be attributed to Alan Turing and a few others, to take the world and all of its chaos and use computing power to go from something that's noisy and messy and turn it into something that's a little bit cleaner and a little bit more robust. That it's got digital systems have in place ways to stabilize analog signals. And I'm just going to breeze by this guy. There's lots of links in here if you want to know some more, and we'll come back to this. It's got its own entire unit understanding this slide. So don't feel like you need to understand all of this right now. But what is useful is for us as we're thinking about what do we do over the next week or two, since by the vote for schedule, I think we're going to have 2 weeks on, or we're going to have a break week coming up next. The AT Mega, oh, that's a good question. Is the AT Mega less buggy than the Arduino board? Is it more predictable? I would say that it's neither, that they're both equally buggy. You might have less problems with the Mega because it's got more memory. You're less likely to hit some of the borders, some of the ceilings in projects that you might hit with an Uno. And what we're going to see this week, while we go into the how-to, I'm going to try and give you some strategies that will make it less likely you'll hit buggy things. So there's definitely some tricks to figure out to try and do Arduino best so that it isn't buggy, but it's going to feel buggy to start. So let's hop over to the how-to part. So Arduino can be daunting. And if you're in that camp of excited and a little bit afraid, I 100% get that. It's very much where this is. I would say that this, for the class, even though it felt like we were doing programming before with websites, I would say that that's a lot of markup. It's a lot of looking nice. And for that reason, it's not quite programming. It's code. It certainly is that, but it's not exactly programming. And I've got an old roommate who was a developer who wrote code for a living for Progressive Insurance. And he would say that he never, ever wanted to write websites, but he always wanted to write code because code and programming is very logical, it's very sequential, and it may end up making more sense than writing websites does. So this, I would say, is our first foray into programming, not our first foray into code. But let's take a look at how you'd actually get that set up. So the first thing, if you're going to write some code with an Arduino, is you're going to need to get it connected to a computer. And even though this Arduino is connected to a project over here, this is a little color sensor, the main thing I want you to look at is the USB plug. That you need to have, it seems silly, but you need a connection to a computer, and a USB plug is easily the best way to get started with that. So this is definitely something that you want to do, and you want to get connected. And then we need to, once it's physically connected, we need to get it connected through software. So I'm going to provide 3 ways that you can connect an Arduino through software to your computer. And the first of these is the one that I totally recommend. And I'll be able to pull this up in a minute so you can see what it looks like on my computer. But the easiest one is the local setup, where you can download and install the latest Arduino IDE from the internet. And if you haven't yet done that, I would 100% I recommend you do that like right now. Just go to the Arduino website, click download, and be ready to go by the time we're done talking here. The second thing that you do once you download and install the Arduino IDE is you plug the Arduino in, you get the Arduino, you open the software for Arduino, and you make sure that it's connected. You go to this tools area and you connect to the port the Arduino is physically plugged into. From here, you write code and it just works. The Arduino IDE can be really helpful. It can also be frustrating. You got to make sure that the drivers go in as it works. Yeah, if it comes up really small, I would say that you want to expand it, and it definitely should be a bit bigger than it should retain its size from opening to opening. So if you save it, it ought to be, if you open it and make it a little bit bigger, and then you save your project, it should save the size of the window when you go to open it the next time. And it's definitely a little quirky. I will say that even though it's a nice polished piece, it's still a little awkward. So don't get me wrong. It's not a perfect software, but it's a nice software. Another way to get your Arduino connected to a computer is through the browser. And this is relatively new, so I don't have a ton of it. I've done some programming through the browser, and I like that all of my sketches, all of my programs get saved in the cloud. That's really nice from this setup. But it's a little bit trickier because browsers aren't really supposed to talk to the hardware on your computer. You have to install a browser extension for USB. But this is Arduino Create, or create.arduino.cc. And if you go there, you make an account and you can write and save all your code in the cloud. You can use libraries that are already saved in the Arduino Create environment. And this is all hosted by Amazon Web Services, by the way. And you can write your code and compile your code and upload your code to an Arduino directly from here. There's even a serial monitor, which kind of blows my mind that they got a browser to do all this. It's like back when I look at this amazed, like back when Google Maps was brand new, and it was amazing that a map that really knew where you were and could lead you directions was all in the browser and live. That's basically where I'm at with this right now, even though perhaps I'm a little bit behind the times. Browsers are more and more powerful all the time. But the Arduino Create is a good way. If you don't want to install something on your computer, really, this is a good way to get your stuff connected. That's a good question, Kate. You're going to be writing code in C++, which is sort of been filtered into Arduino's flavor of code. And we're going to get into that in just a minute. We're going to look at the like start of actual code, but you're writing C++ code. So there's some trickiness to that because it's got that. You can also write your code in Python, but I'm not, just for the sake of keeping us sort of a shared experience, I'm going to just stick to the C++ half, which is kind of the harder of C++ and Arduino, or C++ and Python. C++ is definitely trickier, but it's closer to the real hardware of the Arduino. So it's got some value there. The third option is the Chromebook setup. So if your primary computer is a Chromebook, you can use Arduino 2. This will compile the code, not even on your Chromebook. Last year I used this with a bunch of students that had Chromebooks. You can do Arduino on a Chromebook, but you need a remote server to do the compiling for you. So you can't just like do everything on the Chromebook. You have to send your code out to a server. We were using one in Shenzhen last school year, and then it would compile on a server there, and the compiled code would come back to the Chromebooks where it could be uploaded into the computer. I hope that everything went fine. There was never a problem. It always seemed to work, but it definitely is something that's voluntarily set up and a little bit strange, just that it's something that it's a nice service that someone offers just because they want to teach presumably their own students how this works on Chromebooks. So all of that said, we're just gonna, that's like how you hook up an Arduino and what an Arduino is and sort of kind of other things that aren't Arduino. But now we're going to try and learn how to code on an Arduino, which is, again, primarily C++. And we're going to see in a few minutes that that's an entire thing that I've written up. But we're going to try and go through a series of lessons that focus on this. And so we're going to go through these 5 lessons. And ultimately, let's see, let's hop over to here. These are all hearkening back to this. This is something that I built and put out in the world for the Fab Foundation. So these are a series of lessons that I'm meant to tailor a little bit more for all of you, but our order got shifted around thanks to COVID. So I didn't make the adjustments that I wanted to. This is a whole series of lessons that I wrote up that was intended to take high school students who had zero experience writing any code or with an Arduino and take them from no experience whatsoever up to reasonably capable with the basics of computer science. So these are things that I've written completely wholesale. Maybe they're good, maybe they're not, but it's 10 lessons, and this one is actually done. I just need to update this website that sort of guide you through the very, very first toes in the water of computer science. And so it brings you through all of the different pieces. We start off with just Arduino for math, then Booleans, while loops, arrays, for loops, and more in an order that made sense to me, at least. And I'm definitely a self-taught developer. So those are things that come together, and will help you get there. Without the board in hand is a good question, Kate. How much can you do without the board in hand? I would say it's going to be a little bit tricky to do this without the board in hand. There are some like Arduino simulation softwares out there, but they're kind of hit or miss for what they're doing. I would say that when the Arduino, there's a few of you that have Arduinos already. And for those of you, you might be able to get started right now if you wanted to. But if you're waiting for the Arduinos to come in, we're supposed to have them Wednesday. So just before Thanksgiving. And then next week is a break week. So you'll have a little bit of time. Once you get your Arduino, you'd still have a week and a half before the next class. So you'd have plenty of time to work on all of these different things, all these different concepts, because these were designed to take a long time for a high schooler. My guess is you guys will be able to churn through some of these lessons. Some of you, I'm sure, have experience writing code. So this will just be like flexing the muscles or maybe climbing back up on a bike you haven't climbed on in a long time. And some of you are going to be just learning as you go. But I try to ask the right questions that get you to a point where this becomes achievable. Another thing that's worth mentioning is that we're just going to focus on the code part this week. We're not going to be thinking about connecting it to hardware, because it turns out that's its own whole separate issue. And we're going to get to that later when we're ready. So, and sure, you can absolutely try and play around with that. I'm in no way discouraging you from it, but I think that it would be good to stay focused on one piece just to keep our brains from exploding with too many things going on at once. And definitely when I was learning for the first time, I just wanted to figure out like, what's the least thing that I have to do to make this work? Like, what's the next thing that I have to figure out in order to get it to do what I want it to do? And blinking an LED will be a big achievement. What's up, Kate?
Were you saying that then this week, that because we're focused on the coding, we don't actually need the Unos yet?
Oh, we do need Unos. You'll need them to write code, but you don't need like extra hardware on top of that.
Cool, thanks.
Yeah. So like breadboard and buttons and switches and soldering irons are not something that you should need this week. This is just going to be focused on the code. So you need an Arduino and a USB cord, and that's it. So those will come in on Wednesday and we'll be good to go. Or you might already have one. Yeah, there is an LED on pin 13 commonly on an Arduino Uno, but we're just going to go with the code itself. So If you're trying to write an Arduino sketch, there are a few things that are absolutely minimum pieces that are required. And that's this void setup line up at the top and a void loop line. These, including the parentheses and the curly brackets, have to be there in every single Arduino sketch. Your code at setup runs here, and it runs just once right at the beginning. For the loop, it'll run continuously, and it's got to be between this curly bracket and that one, so that you can run this forever and ever and ever while the Arduino is powered up. So these are absolutely the minimum required things for your Arduino sketches. But you won't need any hardware to play with this. It'll just be the Arduino. You'll need the Arduino and the USB cord, but nothing else to get playing. Let's see. The first one of the lessons that we're gonna try and do, that we're gonna try and move on with, is for the setup. Let's see. That's a good question. Taking a look on. Oops, that was the link to here. The setup that you're going to need is just an Arduino plugged into the computer's USB port. And so I can send out a picture of what that would physically look like, and then I can show you what it is. But the Arduino itself, if we're just rolling back over to one of these and looking at the picture of an Arduino, this USB jack, which has a USB type B connector, you'll just literally plug into the computer's USB port so that you'll have a connection that's very much this right here. So all I'm talking about is, here's your USB connector, the USB cable like this, that's connected into the side of a laptop or desktop or whatever. That's the only setup that you're going to need. So just this alone, you won't need any of this breadboard stuff, all these like lovely mess of wires. You won't need any of that. It'll just be your computer, a USB cord, and the Arduino. So the code is just going to, the code itself, it's a good point. The code is just going to be, what does the Arduino do? Like, what's that chip going to be processing? So you're going to ask the Arduino to do some things. And we'll need to be playing around with just some math to get started. Some of the easiest computing tasks you can ask an Arduino to do is just like some basic addition. We're not even asking about complicated math, just like math in general, to try and make sense of what's going on. And I think that it's really helpful to imagine doing this math, not because we need to learn how to do math or that calculators don't exist, but just because we're learning how to get introduced to the Arduino and sort of like the basics of code. And so on an Arduino, you've got a chip a lot like this one. These are actually little blocks that are the memory itself in RAM inside of the chip. And so you can imagine that each one of these is going to store physically a 0 or a 1 with a physical object that is in one state or the other. And you're going to be asking an Arduino to manage that for you. But luckily, it's way easier than it might sound by looking at an electron scanning microscope or by thinking about these individual blocks with 0s and 1s. The way that this ends up actually looking is much more like this. So if you just take a look at this over here, this is the simple addition program that I've got run, or that I've got set up for us. So in the first assignment, this is one of the examples that will be there. This first bit is setting up a variable. And so you declare a variable named A, you tell it that it's going to be an integer type, and there's a write-up to sort of get you going in that direction to understand this a little bit deeper. So there's a variable named A that is an integer, and integers are numbers like 1, 2, 3, 4, 5. They don't have decimals, and they just are whole number values. And so this is the variable named A. It's got a value of 35, and it's an integer type. This is a variable named B, whose value is 4, and it's also an integer type, which basically for the time being you can kind of ignore because we're just going to be doing basic addition. Then down here in setup, this is the part of the program that runs just one time. And so when you have a setup function, it runs once right as it powers up, and then it's done. It passes it. Once it makes it to the end of that function, the Arduino will run into void loop, and it'll do this forever continuously. And you can see that it's just empty. So if you're writing this exact sketch, it will do whatever's in here once, and then it will forever continuously do nothing. So this line, serial begin, sets up the connection to your computer so that the Arduino can talk to your computer. And then The next step, we make another variable that's named C, but we don't assign it a value. The next line after that says that C is going to be equal to whatever A is plus whatever B is. So here, this is the actual line where math happens in this sketch. There's a fair amount of things that go along with this, but the setup is just a function that runs one time right as you power on the Arduino. And from there, it's going to communicate with the computer. It gets ready to do some math. It does the math, and then it tells you, this is saying on the serial monitor, you want to print out this one line that's just got the value of whatever C is. So it's going to take 35 and 4, it'll add them together, and it'll tell you that the answer is 39. That's it, which doesn't seem like a very interesting program, but it's absolutely the first step on getting to understand how you write programs, how you make sense of programs, and sort of how this entire ecosystem works. You write this code, the Arduino IDE magically takes it and rolls it into something that's useful for that chip. And then you can put this code on the chip and it will tell back to you the answer to a math problem that you ask it. And the fact that you're able to control at that granular level is really powerful. That you can give instructions to a chip, that it can do things back to you, that it can communicate, that it can give feedback. All of that is super important. It makes it worth learning all the rest of these other silly tidbits about it. And one of those tidbits is like, because there's physical memory that you have to take into consideration, you can't just put any number you want in a variable. When we call these things ints, there is a limit. They're 16 bits, so there's a range. If you go beyond that range, it rolls over to the bottom rather than intelligently knowing that it should round off or make the number bigger. What's really interesting is that the maximum value in an int is 32,767. And if you get 32,768, it doesn't go down to 0. It interestingly goes down to this number, which is the bottom end of that. It's very bizarre, but it's a predictable pattern that you can work with if you happen to need to. But that's just one of the many things that an Arduino can do. And I want to just buzz through really quickly a few more examples. And I've got a bunch more that we can look at and we can talk about, but maybe we'll skip until after show and tell. But I just want to buzz through Booleans because I think that it's also really important as a concept. So within computers and computer science, you've probably thought about computers have just a bunch of zeros and ones. Well, zeros and ones are handled by Boolean logic or Boolean algebra. And Booleans are going to be really powerful for us in Arduino because they give us sort of a scope of things to think about. They give us an easy way to imagine processes, and they show up in the real world too. Like here's some electrical switches. You can very reasonably think about electrical circuits as Boolean operators where there's and or logic. And if you want to get really fancy, you can go deep into the weeds on and or and not and nor and XOR and NAND and all of these different variations. And these concepts may feel really foreign, but this is something that even though it's in, I don't know, Portuguese, Spanish, one of those, these two shapes, A and B, these could totally be the interface for Illustrator or Photoshop, or for Illustrator or Corel or Inkscape, where you have shapes that are A not B or B not A, or you add the two, or you just think about what if not either, but where they're both true, or not where they're both true, but where either is true. You can think about them in sort of a shape geometry kind of way. You can think about them in a numbers way. There's lots of different ways to think about this, but this theme of Boolean this or that, yes or no, is often really helpful inside of programming and computer science. And so there's definitely a lesson where you can play around with that and you can explore. But one of those is where you'd consider something with a couple different variables. Like here's a variable and it's a Boolean type variable. So these values can only be true or false. And true and false have synonyms, like true is the same as a 1, or the same as having a high voltage of being 5 volts on an Arduino. And false is the same as a 0, or the same as having 0 volts or being at ground on an Arduino. And so having Booleans that you can play with is a really useful tool inside of an Arduino sketch. So in the same sort of way, kind of like there was math before, you can run logic. Like if A and B are true, then tell me I like cookies. But if A and B aren't both true, then the other option, or else, you should tell me that ice cream is nice, right? And by, even though this may seem weird and sort of otherworldly at the moment, by playing around with it and thinking about how do I link these things together, it will really quickly start to become a thing that you can toy with. You'll learn what do you need to pay attention to and what do you get to ignore when you're writing a program. And then there are people who get way deep into that. There are certainly entire career fields all centered around programming, and we're not going to go too far into it. But when you think about all of those different things that a programmer could know, this is the very start. However, I've seen really elegant things come out of super simple logic. And this is a really good scope for an Arduino project to live in, where you can say, if this and that, I want this third outcome. Where you can start to make statements like that. You can have all kinds of structural operators, all sorts of links, but just starting to play with and explore these relationships, these concepts of Boolean logic, or what we'll see is while loops, or data arrays, or for loops, these different like ways of thinking like a computer or like a programmer, they're going to be really helpful for you as you're starting to explore these different concepts. For the sake of time, I'm going to say let's keep moving forward. There's a couple slides at the end that I want to get to just to make sure that we get to them. But as we do, we'll come back to these. So what are the things that you need to do now if you're really going after this? So what are the next steps over the course of the next 2 weeks where you're working on just this one unit of Arduino? We did the vote, and the vote said that we're going to have a break week right after this. So you'll have a little bit of a cushion of time to process all these Arduino ideas. And if you need anything, I'm not going anywhere. So you can always message me at any time. Some good next steps are to do some troubleshooting. These are some of the most likely problems that you're going to run into if you're trying to do this stuff. Forgetting to plug in the Arduino is going to be our problem for the next 2 days, right? Until you get an Arduino in hand, it's going to be hard to make any progress on this. You can do some background reading, you can do some things, but really it's the playing with it and poking around inside of code that's going to help things go right. This list is probably going to be something that's good for you to reference later when you're actually doing the work, but you'll often find that a semicolon is the master of hide and seek in programming. Maybe you'll be trying to use an Arduino library, probably not this week, but maybe in the future. One of the things that's tricky about all of those Arduino software connection things, all the IDEs, is that you'll need to remember to connect it to a USB port or to the COM port in your computer. Whether it's the Arduino IDE, whether it's Arduino Create, Chromeduino, or you can even program through VS Code your Arduinos. Those are all available options, but make sure that you identify where your Arduino is plugged in so that it can do it. The same deal, you would need to make sure that if you're talking through your COM port, that you've got all of that connection working out really nicely. A good question, does the IDE show syntax errors? It does. And so one of the things that's really nice about Arduino, and I wanted to pull it up and actually show you, is it's opening for me, and you can see the window is super tiny. But in here, if we go to File and Examples, there's a bunch of examples that are built into Arduino. And so if you just go to File, Examples, Basics, Blink, this is an example sketch that is, it's small, it's maybe a little bit simplistic, but and we're going to get to that slide in a second. But it does give you a chance to start and explore all these different concepts. And there's a whole treasure trove of different examples where you can start to think about, well, I want to do control. And so you can look at arrays, you can look at other stuff. Oh, by the way, this little tiny window, how it pops up, just make it bigger. It can be frustrating that it doesn't seem to be the smartest software. It's definitely meant to be for makers and a little hacky. That's okay. We all deal with it. The key here is that you've got lots of these things to play with. And by watching videos, playing around with these, that's how you learn how to code. You can absolutely get a degree in programming, and that will be very helpful. But if you're just trying to figure it out this week, just playing is a really effective way to teach yourself. most of my coding knowledge comes, I would say more of it comes from playing around than from having taken any sort of formal classes. The amount of officially being taught to code that I've done is pretty meager, but I feel like I'm reasonably good at it with some experience and background. I'm certainly not a professional, but I can make my way through some code. But it'll start to get you to think in logical ways by seeing examples of how other people write it. And so looking at other people's code, reading through it, making sense of it is really important. It's something that when I taught this to high schoolers was really hard to get them to do, to read other people's code or to even be able to ask good questions. But I trust that you're all going to be able to do that much better as adults. And so it's tough, but it's still very hard. So don't let me undermine the fact that this is going to be tricky. If you're brand new to code, it's not going to be something that you immediately hop into. Most people, it takes some effort. Just like with all the other things, it takes work to get better. And you only learn when you're wrong. You'll often try and write code and find that it doesn't work. That meme at the beginning about the dog and the developer, those are definitely big feelings that you can have while writing code. And so what are sort of your next steps for this? And I'm going to show you exactly what I want you to do for the assignment, just as a guided, structured piece. If you're not really sure where to even start from. But your next steps would be to pick through example sketches in the Arduino IDE to sort of look at those, read them, see if you can anticipate what the outcome of those programs would be. Play around with some simple changes to those examples. They're there to be poked around with, to find what you understand and what you don't. They're definitely there to help you explore. And then also a good strategy is to try hooking up LEDs. There's tons of tutorials on how to connect things to your Arduino. And if you already know the basics of code and you're ready to start that process, go for it. Try and do a little simple Arduino project for this week. That'd be really fun. Another interesting part is to think about the style guide. Like, how do you, thank you, Timekeeper. Another good piece is to take a look at the style guide for Arduino. When you write code, one of the things that isn't necessarily important if you're a hobbyist writing code for just yourself, is how you write it or how it looks. But if you're writing code that anyone else is ever going to read, or if you're trying to write a library or something that other people might use, or if you're writing it as a part of a team project, having a sort of style guide to inform how you write your code is really important. Businesses definitely have style guides, and languages have style guides for how they want their code to be written and read, because maintainability is something that we'll definitely talk about in the next lesson on Arduino. How do you write code that's a little bit better for going back and editing things? Because you should always feel ready and capable of editing the code that you've written. So there's good strategies like explaining your code at the start, putting in circuits and some other strategies that you can use as you're trying to explore how do you write your code, how do you make it look nice. And then you can also think about, while you're writing code, how do you write code with less repeated lines, with fewer repeated phrases? That's a really important part. As you're trying to get better at code, how do you isolate the things that you need to change if you want to change it? Like if you want to blink an LED on and off 5 times in the course of one cycle, how can you write your code in such a way that instead of giving the same command 5 times, you get it to cycle back to one location in your code? And those are more advanced tricks and tips that we'll get into, but they're really good ways to try and isolate the strategies of coding so that you can code smarter rather than harder, right? That you're writing things in ways that work well, are somewhat elegant, and are nice. But that takes a long time to get to. I've written a lot of really bad code, and it's super important to do while you're getting up and running. You want to write something that works at all, and then just be excited about that. Don't worry about making it nice to begin with. And I think that's maybe the theme of this entire class. You just want to try and make it work, and then you can figure out how to make it nicer on the second pass. It's a part of the iterative cycle. And then one good thing, if you figure out everything that's going on with this week, you can definitely continue on or try and take on some cool Arduino projects. And it was really neat to see people linking to those in the Foundations chat. But what I really want you to do, my recommended thing for everybody who's new to Arduino, unless you've already built 5 or 6 Arduino projects and you totally know what this is, or you've got a degree in engineering or computer science, I think that this would be a good place to start. Whether it's to, brush up on your computer science skills, or whether it's just to get used to the weirdness of Arduino, hammering through these assignments. I wrote these for high school students, and I'll put a link to this. That's a really good point. Here's the link, and here it is right here. These are the lessons that I wrote, and these were intended to be for high schoolers who are just starting to learn code. There's code in here that you can copy paste right into Arduino, and it will be lots of stuff that's in there. There's sort of questions that I wrote to guide them through. And even though you're not high schoolers, sometimes these questions, it's nice to feel like you can do what you need to do. And a big part is to read these comments. Ooh, one important piece that I think I want to make sure I emphasize is anytime that you see a double slash before a line, that's a comment. And then another place where that shows up is if we're looking at examples, you can also have comments that are preceded by a slash and a star. So when you're reading code in Arduino, it's this colored stuff. That's the code. And the other pieces are all comments that go along with it. Grayed out text is comments in almost all IDEs. That's the format that you're going to be used to seeing, or that you will get used to seeing. But these lessons all guide you through sort of the weird ideas. Like this one takes you through the concept of what happens when your number gets bigger than that limit, and what's the behavior. And it asks some more questions to get you to explore these ideas in a sort of structured release kind of way. So you can do all of that through these lessons. You walk through sort of the Boolean logic, while loops, and arrays. If you make it through 4 loops before we get back together for the next class, which is going to be on December 7th, if you can make it to 4 loops, you'll be in a good spot. The goal is just to get you through here. And if we were to back up and think about the foundations class a little bit more broadly and sort of where we're going and look at our units. So we'll head over to units. We're in embedded programming now, which is a little out of order. I get that. We moved 2D design and making to be after. The next thing would be intro to electronics. That's going to circle back. And we'll think about sort of the logistics of how do electronics work and how do they function. So how do you get the electronics pieces to connect to the Arduino, and what are they doing? How do you think about switches in ways that we've talked about, but we haven't really formally studied? How do you start to think about those processes? And then there's an electronics and inputs and outputs unit where we really bring those two concepts together, the electronics part and then also the inputs and outputs part, so that you can think about the switches and light bulbs and LEDs and solenoids and motors. How do you process those things with an Arduino so that an Arduino can be in control of those? So that if you wanted to, you could build your own lights that turn on for 6 hours and then they turn off for 18 hours and they come back on to start the cycle again. So we've got several units to try and unpack all the stuff that comes along with Arduino, and then they'll globalize to Raspberry Pi and all those other things neatly. But it's going to take us multiple units to really unpack that. So do not feel like you have to get it all in the next 2 to 3 to 4 weeks. We're going to take many weeks to try and make sense of this. So it's going to take some time. Just stay focused on the code and how to get all of these pieces to work in your head, so that if you came to a point where you wanted an Arduino program to do some math, you'd be able to make that happen. Or if you wanted to do some Boolean logic, like I think I talked with many of you about building a door alarm so that I could check and see, if somebody's okay inside of a bathroom, or where there's a motion sensor and a door latch. And if the door's been locked, but there's no motion in the room, I should go in and check on the person, right? These sorts of simple logical things. How do you make this kind of a connection happen so that you can make like a simple system that would be just a motion sensor, a button for a door to tell if it's open or closed, and then an alarm, right? How do you get those simple connections? The electronics are one thing, but then the logic is its own separate piece. And this week, we're just studying the logic part. Once you have this, it'll be definitely something that we can take a look at and explore to try and make better sense of what's happening. But that, I think, is it. And we're probably at it for time. So I just wanted to, we got a minute left. Interesting two more interesting concepts, three more interesting concepts before we hit our 9, 10 exactly. There's while loops. This is a really useful tool where if you have a program that you want to do something, like the Roadrunner here wants to run right up to the edge while he's not on the edge, he wants to run. But when he hits the edge, he wants to stop running. That's often really helpful in programs. You'll explore how while loops work, where you can say, while one condition is true, do something. And when it's not true, stop doing that. And so you can use that to lock up a program forever. You can also use it to say, I want you to do this until the kettle is warm enough, right? Keep warming it until it's hot enough, and then stop and do something else. They can be really useful for programs like that. Then there's data arrays. So how do you process information with an Arduino, and how do you store it in a logical sense? It turns out a train is a pretty good analogy. You're allocating memory blocks or allocating train cars. What might be in each train car can be different, but since they're an ordered set, you can process them as a group, which turns out is a really powerful trick and something that's super useful in Arduino. And then once you have arrays figured out and while loops figured out, a next connection is a for loop where you can say, I want to do something either to a set of data or to a defined amount of cycles. You can use a for loop to cycle through something a certain number of times in a certain number of ways. And these are really useful tools also if you want to have a pattern that emerges in the way that your code works. So there's tons of interesting things to learn with code. And the lessons that I have laid out for you will hopefully get you to explore those so that you can try and make sense of them. So that when you have a project in mind, you can think about it hybridly, like what do you want it to do and how would you get the code to work so that your thought processes for those are integrated rather than separate things. And that once that becomes true, once you really start to think about how would you solve this as a coding problem at the same time that you're thinking about how would I make the electronics work, then you get a really integrated process that lets you imagine more successfully how a project will unfold. So that said, I think that we should probably stop. I should see if there's any questions. There's definitely stuff going on in the chat. And I want to hear what happened for you all the next week. Oh, also, edX has a free class that explains this really well via Super Mario CS50. That's a really good one. Yeah. And it might do it for loops. Yeah. Yep. So there is that. Let me stop presenting. Oh, I don't want to share. I want to stop sharing. I want to see all of you.
It definitely covers for loops because that one was really confusing, and it's like a whole homework assignment for loops in Super Mario Brothers, like with the pyramids, like having it. Well, I won't get into it, but it's worth checking out if you get confused and you just want to learn the coding.
Yeah. Yeah. And I think that we're going to stay just focused on the code these 2 weeks because they're tricky enough that it's worth taking the time to understand them rather than just hoping that the code you find on the internet works for you. Kate, you are on top of those links. Way to go. All right. So there, boom, look at that, right on top of it. Okay. So show and tell time. A lot could have happened this past week. A lot might not have happened this past week. There was certainly a lot happening in the world over the past week. And so I just want to hear from anybody who wants to share, like what happened to you? What were you working on? Did you make a lamp? Did you finish up a project? Were you imagining what your final project could be? Because there's a lot of different options and there's no wrong ones this week, which is great. Not that there's ever a wrong one, but there's lots of different opportunities. So it's good to hear what everybody did and sort of how you're doing.
I worked on something a little bit this week. Besides getting the heater going, I'm trying to do a proof of concept with like an alarm system in my car. So today I started off with just going back to the basics of an LED and a photoresistor. And when the door opens and light shines in, or more light shines in, that would set off the buzzer. So I tried an if statement, and it's not working quite yet.
Yeah.
I'm just doing basic like high and low. Like if the light is on, which in Arduino you would put high in all caps, then the buzzard is high. You know, if the light is low, which is off or 0, the buzzard is 0 or off or low. You
Yep.
can say in a lot of different ways. There's more than one way to skin a cat, I think, in programming language.
Cool. Yeah, there's tons of options, and that's a really good starter project. A lot of people, I think, when they hop into Arduino, they want to take on a big, grandiose project, but just like a simple, if this is true, then do that, is a really good place to start. Just because you want to do like 5 or 6 of those before you hop into something really complicated, just to get acquainted with the environment, like how do you get your programs to work, how do you get all that logic to run, is really cool. So I hope that it's going well. And if you want any help with the circuit, like sometimes it's good to just read, like there's a lot of tricks that you can learn. Like if you've got your light sensor, what might be helpful is just to have it output through serial monitor what state it's in, and then like open and close the door. So you can sort of make sense of what is its real feedback being. And then from there, once you know the output, you go from that point. Cool.
I would love to
and
ask.
Using like the reading.
Yeah. Yep. Using read. What's up, Kate?
I was just going to say, I would love to hear from people as we go through. I'm getting a feeling for Jamie's experience level, but I'm just curious what various, what other students, if you've used Arduino or Raspberry Pi or other microprocessors or none. I'm just kind of curious where everyone's at for that, if we could throw that into your show and tell piece.
Oh, I think that's totally a good ad. I wasn't gonna. Yes. So what happened last week, and do you have any experience with Arduino programming, whatever?
Oh, yeah, I have some. I started off this summer, during the COVID actually, so it was probably more like March. I got a cheaper Lego kit on Amazon, and it was like a starter pack because I had always wanted to learn electronics, and I was in a situation where I need to run it off very little power, so I also got a Raspberry Pi to run it, and that's how I just spent like my COVID learning coding in Arduino. And I still feel like I don't know anything, but then every once in a while I feel like a god.
Yeah.
And then
it's pretty much how it goes.
But so
cool.
I have a few months worth, and I'd be happy to help anyone who
Yeah, that's awesome. All right, next up, looks like Wagata and Ben are both unmuted. You guys want to share either?
Yeah. So I haven't dealt particularly with Arduino, but I do have past coding experience. Fortran is kind of an obsolete language right now, but I think this week will be easier for me.
Cool.
With regards to the programming. And likewise, if anybody has any questions and stuff like that, I'll be doing some relearning this week as well. Yeah, just reach out.
Awesome. Did you do any building last week? I know you had a busy couple of weeks, but did you get to make anything, or were you?
No, but I'm really interested in a swag lamp. So my apartment kind of looks like a fortune teller's room. It's kind of dark. So I could use quite a bit more lighting in here. And I think the swag lamp kind of hits that.
Yeah.
So some, I guess, goals that I want is most of the room to be lit up, but not to hurt your eyes as you're walking around. So I want it to kind of be angled, but the shading, I want it to be clear enough to kind of just illuminate the whole room.
Yeah.
So I'm just kind of getting started with thinking on that.
Cool. There's some really cool like paper lampshade ideas, or Anna's making some progress on an acrylic lampshade. Ben, do you want to go next?
Yes. You say I'm not muted, but I join with my phone and then I'm like muted on my phone, which doesn't appear on the Zoom, but I don't mind. I just, anyway. I made this kind of bizarre wood brass triangle connected thing. I guess I was kind of continuing my wood and brass kick because I enjoyed that with the little coffee thing. And then I haven't yet executed it, but my idea was that this could hang with like a light bulb kind of suspended in the middle. And I have one of those light kits, Corey, that you showed us last week. So I purchased one of those from Home Depot, and I haven't yet assembled the whole thing. And I only have a vague notion of how I'm going to assemble the whole thing, but putting it all together will be the next piece.
Yeah, no,
I have no experience with Arduino on that other topic.
Gotcha. Cool. Yeah, the lamp sounds really cool. I'm imagining like a really, and maybe it's not what you want to do, but like a really thick rope, like paracord or something, where the knots are very visible and like it's got a really cool look to it. Or you could do like totally invisible lines where it's like fishing line and they just disappear. If you really need to.
Well, and the other thing is like this thing can like kind of sit on its side. So there's also a version where it's like a very clunky and awkward desk lamp. So anyway, we'll see. There's like, anyway, lots of versions.
Cool. That's awesome. All right. Anybody else want to go next?
Sure.
Sure.
See everybody. Oh, okay.
Oh.
Go ahead.
No, Aaron, you can go.
I'll be pretty quick. So I don't know. What have I been up to? This toilet light thing. I didn't get a chance to show it off last week. Let me see if I can flip my camera around. So I've been wanting to make this forever. Not that I'm having a bunch of people over and I'm not sure, but basically like the bathroom's over there and I don't necessarily know if there's anyone in it. So, this way, rather than burn a calorie and a half, you can still sit on your desk and know that there's, someone in there. And I don't know, I got a lot out of it. And then the chopsticks that I finished, my place is kind of a mess right now. Are right here. And they were extremely easy to make, just using like a food grade aluminum. And I'm trying to eat slower, so I think switching to chopsticks is going to be the way to go. And then the other thing that I've been up to is I've been slowly rebuilding my PC, and then today I went like kind of whole hog. I got extremely lucky and got a couple of components that are kind of difficult to get right now. These lights are really gaudy, and I'm still not sure that I like them. But during COVID, it's been exceptionally difficult to get computer components, so I've sort of ended up making a really nutty thing. But yeah, right now I'm reinstalling Windows and trying not to hate myself. So that's it. That's what I got going on.
Yeah, it's a good example of when you have to reset your operating system. It can be rough.
Yeah. But to my credit, I rebuilt the whole computer. I mean, like soup to nuts. Earlier today, I did the thermal compound. I did like a new CPU. I've never done that, so that was kind of cool.
Yeah, that's awesome. It's a really it's very empowering to build a new PC.
It is really empowering. I'm feeling pretty good about myself right now.
Good.
So, anyway, if anyone has any questions on that or anything like that, I'd be happy to do like anything I could to help. But for Raspberry Pi, I've got a pretty good amount of experience with that, so happy to help there too. And also, I think one of the things that I'm not an expert by any means, but I would love to read other people's code. I feel like that would help me just because I understand like syntax, and maybe we could help each other because I too have like zilch experience when it comes to coding on Arduino platforms. So maybe there's something I could give and then something I could take,
Cool. Yeah. That'd be neat. Ada, do you want to go now?
Sure. Yeah, it's just a quick update is that so I got the Gerber CNC to, or I mean not I personally, but the many people, Corey, Leor, Andrew, tiny bit, maybe me, but we had the Gerber working, and so I started cutting the pieces for that nightstand again. And they were coming out great, but then the Y motor stalled twice. And so now they're in the process of replacing the motor once again. So uh, I I've only been able to cut maybe about a third of the pieces or so. And part of the bedside table is that the second level is supposed to be a built-in light. And so in terms of like designing a lamp, I was sort of thinking about it in that way. And then also this might be a better this might be like a simplistic enough computing task that it would be better for us like a smaller board than an Arduino Uno. But the stand is going to have these copper inlays on it, and I want to program it so that a little microcontroller could turn the LED light inside on and off based on touching the copper inlay and sensing that. So that's like one thing that I want to think about doing for Arduino sort of stuff. I don't think I would need a whole Uno to do that.
Probably not, but you'd want to look into, and definitely you want to learn the basics of the programming, but there's a capacitive touch library that's really neat where if you just touch a metal, it will act like a button. And that's actually your phone screen works through capacitive touch is how it figures out the location of your finger on the screen. It's got little micro wires that you can't see, but it uses your finger like the other half of a capacitor to tell where it is on the screen and like how you're touching the glass.
Yeah, so I watched a few videos about creating capacitive touch switches, which is partially why it seemed to me like you could do a much smaller controller than
the Uno. There's the Pro Mini is a good place to start if you're just trying to get something small, but you don't want to remove the board itself. If you want to get down to just the chip, you totally can. But it's definitely like I'm already good at Arduino. Let me try.
Yeah, I mean I've never programmed for an Arduino before, so I think I'll keep the board for now. I mean, for this unit, I think I'll work with the Uno that comes, but just when I'm able to cut the rest of it and assemble it, and I'm getting ready to do this capacitance switch, maybe get a slightly smaller one.
Cool. Lila, it looks like you've got something awesome there. Do you want to tell us about it?
It's not complete, but I guess it's kind of like we were talking about, beginnings of ideas. So I made this, it was going to be like a dodecahedron that stands on something. I don't know. I have this so it can kind of show what it might look like. And I thought it would put more of like the pattern on the wall, and it doesn't. Maybe it has to do because that's an LED light and not a light bulb. I don't know, but it's the beginning of something. I just don't know what.
Yeah, that's really cool. I think if you wanted it to project the shadows better, you'd want to get as small of a light source as possible. So like a single point source of light, if you can, will throw a better shadow.
Yeah, I lasered it today, and I guess I am behind on other things, but I did play a little bit with the kerf, and I really wanted these to fit perfectly in here so it sticks together. So I practiced and kind of went ahead there where I may have fallen behind. I just got badged in I cannot think of the word for it, but I really wanted that badge. What is it? The one with the metal and you melt it together.
Welding.
I
Yeah.
just got badged in welding finally, which was great. So I'd like to practice more with that. And I was going to do it earlier in the week and it didn't happen. And it kind of set off a whole bunch of events that led to more unfinished projects. So one being another tufting gun project. And I also got my badge on the lathe while I was
Yeah.
not getting my badge earlier in the week. So, I mean, I tried to make use of my time at MakeHaven, and I mean, I got stuff done, but nothing is completed. So I started stuff. Yeah. So if anyone ever needs help with lasering stuff, I'm okay at it. I'm not like perfect, and I'm still kind of learning, but I like playing with the laser. It gets a little tricky, and I'm good with vector stuff. So if anyone needs help with vector, I don't have any experience programming in Arduino, but I'm looking forward to it. I think I could do it.
Cool. Yeah, that sounds great. And laser and vector is where we're headed right after Arduino. So you just sort of flip the schedule around a little. That's
yeah,
fine.
I tried to make use of time.
Yeah. So cool. Ruby or Anna, do you want to share?
I can go.
Yeah.
Hi. I don't have any experience with Arduino, and I guess coding in general, but as we're like going through like with like the other class that we did and this, I am starting to get less intimidated. I'm excited to study this, and we're gonna get there. This week, I was really planning on finishing or getting more comfortable with welding, but it just didn't happen. So instead, I focused on maybe or on stuff that I haven't been able to get to, which is like getting my website and making it better and updating it. And then I've been trying to figure out stuck on the wearables, and I like met with Corey today, and I think the problem is like either the battery or like the way that I maybe like soldered it. I don't know. We're gonna figure it out. It doesn't. I'm not in a rush for it, but I did end up finally making a mask that's reversible, and I'm planning on finally getting that done. But besides that, I did make a lamp, and I need to show you right now.
The lamp is so cool.
This cloud behind me, it's wireless and it's on a timer. I bought twinkle lights from Target for $5, and here, I'll turn this back on. So there's these like seasonal like twinkle lights from Target that are $5, and it gives you the capability to have it on a timer. So you turn the timer like button on, and it turns on for 6 hours continuously. It shuts off after the 6 hours, and then the next day, like or 18 hours later, it turns on again at the exact same time. And it kind of blows my mind, because I like it's really cheap, but it does that. And like I always wondered how you sort of get there, like I guess like how does it actually happen? And I didn't know there was an actual word for it, so that makes me like even more interested in what Arduino is. And yeah, that's where I'm at. I'm on a roll here, and next I'm gonna slay the welding dragon.
That's awesome.
Yeah.
Yeah, I just pulled up twinkle lights from Target, and they're probably a slightly different brand than the one you've got, but they're really neat. They're commonly twinkle lights are essentially just the LED sequins that Adafruit had, but like put directly onto a wire instead of having a little board, right? And so is that what you've got for yours?
Yeah.
Yeah.
So, I mean, I'll show you. It's
Oh yeah, they're the Wondershot brand thing. Yeah, cool. Those are totally there, and it's just like essentially at its core, it's just got a little teeny tiny Arduino that's running the brain of the thing. And so whether it may not be an Arduino directly, but it's definitely some sort of a processor. Yeah,
crazy.
it is. That's very much something you could be building. So that's cool. All right. Anna or Kate, either of you want to share, talk about what's going on? I love that lamp.
Okay, I'll go.
Yeah.
And I'll tell you about how I didn't make a lamp. If you came, if you weren't here earlier when I was mentioning that I had this plan, I got some lights from IKEA and have since learned that there are string lights where you can't remove the bulb, which Ada has told me is sort of an LED thing and maybe more common than I ever knew, but it was new to me. So I got the measurements was just right, but not so right when you can't take the bulb off. So that kind of thwarted those plans, but that's okay. Because, I have other ideas that aren't quite together yet. But I did want to try, I can show you really quick. Oh, and as you probably have gathered, I have no experience with Arduino or other microprocessors. But in silliness, I will show you, I did have, you seeing my screen now?
Yep.
So I did have, I did not make a lamp this week, but I did melt some wax and make fire starters. So
There
that
you
was
go.
exciting. And also made some candles while you're melting wax.
Yeah.
So, there was some stuff happening. And then I finally got the printer. Ruby is here's your cameo in my blog. And I got the printer to work and made a little banner for my porch. If anyone wants to come and paint my porch, feel free. But it was very exciting to get to try that that new printer. And I'm
Yeah.
super excited that it's in MakeHaven. So that was
Yeah.
my
That's-
non-lamp week.
That's so cool. There's tons of the lamp was totally optional. Plus, you built a lamp already, Kate.
Right, that's what I was thinking. Like, let's not try to go. Let's not do.
Yeah, yeah. Just no need to double dip. There's so many cool things to build, and the printer that size is really something that's neat. I've been thinking about how can I build something very large out of origami. Like if there's big paper that we can pass through and print just like fold lines, how could we make a big origami structure is what I'm thinking about. Like a giant origami crane or like a dome to put over a chair would be really cool. Yeah. And then let's see. Anna, are you around? Would you like to share anything?
I'm actually in twice because I don't have a camera on my desktop, which I'm looking at. So I have to use a camera on my phone, but it doesn't do audio very well. So we'll try our best.
It sounds fine. So you're good.
So this week I tried TIG welding, which is a much more manual form of welding. My partner has a rig, and I kind of like have been pestering him to teach me for some time, and we finally sat down and did it. It's like a lot more. There's nothing automatic about it. So if your hand is shaky, you're going to screw up. If you dip the tip into the melted metal, you have to go and basically like not sand it, grind it off so that you can continue welding. And I mean, I also am not very comfortable with not being able to really see what I'm doing because you have to have that protective mask on. So that really threw me off. Like there were definitely several times where I almost went off my piece of metal because I didn't know I was at the edge of my piece of metal. And so my partner had to reach over, who was also wearing a mask, and like push my arm so that I wouldn't go off the edge. Not sure
if I'm going to successfully make anything with TIG welding, because I had a couple of mistakes that they didn't bond properly, or I melted them too much, or a million different things went wrong. But definitely easier to TIG weld for short people because I could sit at a desk and do it, rather than standing and having to like use this like really big thing. It was like a lot easier for me to hold it and use it. And I had like, there was a pedal that I could just press like a sewing machine, so that was very natural to me. And there's like boron gas that you have to turn on that like cools it. So that was like my TIG welding experience. I started like basically drafting my idea for a lamp and doing a bunch of research, and I kind of got lost in a YouTube rabbit hole of information and details, because I'm trying to, much like what Lila's doing with the dodecahedron laser cut wood, I'm making an icosahedron, but that's stellated, which basically means it just looks like a star. And I'm doing that out of acrylic, but I have to make sure it's the right thickness, and there's a bunch of research into the best way to adhere it, and then I have to make sure there's room for the bulb to go in, because I'm doing a pendant lamp and it can't be too heavy. So I've just been kind of getting lost in the details, which I'm trying to do better at, like pulling back and being like, okay, let's just test things. And yeah, that's what I got.
Yeah, no, and it takes a lot to like have that moment where you're good testing things, and it may or may not go well the first time. And that, yeah, it definitely takes some adjusting to get to there. But I built a lot of really bad things, and I want everybody to feel okay building something that's really bad, just so that you can learn from it. Because usually it's those things where you get something wrong or it goes weird. That's the moment where you learn the most. So
can I just add, Anna, I totally relate to the whole welding like in the dark. It was just like this whole very weird experience. I've done 0 TIG welding and then this much MIG welding, but when I was badging with Brandon, he talked about doing it a few times without any, just moving the torch and kind of building some muscle memory before you start it. And I found that to be super helpful, because yeah, it's weird when you can't really see. I also just wanted to put out a reminder to everyone to please put your projects or pictures of your projects in the Made at MakeHaven Slack channel. We're going to be posting some of our recent makes, and I know there's a lot of really cool things I've seen come out of this class that I wanted to include. So that'd be cool.
Cool. Yeah, that's exciting. And while you're doing that, don't forget to continue to take pictures, continue to think about your portfolio. We've sort of gotten away from showing the portfolios as we go, but as we move through a couple break weeks, it might be good to revisit that. If you've been avoiding it, and I can understand that, I've definitely avoided documentation at different times in life, this may be a perfect opportunity to spend a little time getting reacquainted and trying to build up that documentation, just so that it's there. Also, don't at the same time, I want to say, don't make your life double extra hard by choosing the most complicated form for documentation. Do something so that you can do it effectively and it doesn't become the focus of your life. Instead, let the projects be that. The documentation should just be something that hopefully comes together quickly, even if it isn't, even if it's something that you'd want to touch up later, if you're going to share it very, very broadly. But it's good to have it written so that you can change it rather than to fill it out, to do it all completely after the fact.
I'm gonna have some staged photos for my metalworking week. I didn't get any pictures, so.
Oh yeah, we'll get you some. We'll like, when you're in there, we'll just have somebody walk over with a camera and just like photo shoot time. We'll got a glam shots in the metal shop.
I definitely was so entranced by the horizontal bandsaw and like enjoying the auto feed so much. And when it ended, I was like, that would have been a good video. Like it was like, oh well, you know.
Yeah. Well, it's incentive to make more stuff, right? Get more photos. Just make it doing it for the gram. That's the kids don't say that anymore, but they should.